Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen vanuit DevWorld in Amsterdam. Jan.
Hallo.
Ik ben ook nog een keer.
Ik ben helemaal van mijn apropos.
Dat was ook de bedoeling.
Hey Ronald, wij gaan het heel technisch hebben vandaag.
Nou, ik hoop er een hoop te leren.
We hebben een gast die terugkeert.
Zeker. Een goede vriend van de show.
Zeker.
Alessandro was daar. A good friend of ours learned me how to pronounce it. Just remember the word pizza.
Yes.
You know probably who I'm talking about.
Yes.
Weet so. Alessandro, welcome for joining us again in the podcast.
Thank you for having me.
How are you been doing?
Great. I finished my talk, so now I'm in relaxed mode. It's Friday, and there's a boat for us waiting, right? So there's a boat party after this, so
we need to make it work.
Well, excellent.
You talked about was eBPF.
Yes.
I've heard a lot about eBPF, but can you explain it to me? What is eBPF?
Yes, of course. It's some people call it superpower for the kernel. I use the word cheat code. It's like a cheat code for the kernel. Actually, I put this GTA 5 cheat code.
Oh, that's the only one.
No, they don't work. They don't work. I tried it, and don't use them. But for the kernel, please go ahead and cheat. The cheat is you can convince the kernel to execute arbitrary code that you write in user space. You can inject it in the kernel and let the kernel run it upon events. Kernel hooks are these events that can be triggered by new file being created or a packet arriving on the network card. And so you can, now the sky is the limit, right? So you don't need to go through.
But normally you can't. Because you've got in the kernel for you and maybe for some of our listeners, you've got more spaces. You've got rings.
Yes.
Is it?
Yeah.
You've got the not the user space. That's the ring one.
Yeah.
And that's the ring he speaks to devices and you've got the ring 2 and that's user space. And ring 1 and ring 2 cannot.
Yes.
Talk.
Which the kernel is a sacred space, right?
Yeah.
So because if you break the kernel, it's game over, right? So that's you, and you got this amazing guy, Linus Torvalds. Of course, we all owe Linus what we are here because of his genius of rewriting the Unix kernel. So he is the guardian of the kernel, right?
Yeah.
So, and that's good. It needs to be like this. Even recently, Rust was included. Some Rust code was included in the kernel. Took years to get there, right? So maybe things are getting more fast in the development. If you think Kubernetes is slow, because they release every 3 months, but to get a new feature in Kubernetes, good luck with that. The Linux is even more slow.
But it needs to be stable.
Of course, it powers anything from hospitals to nuclear power plants. So it needs to be stable. We need that. But on the other hand, you don't want to stifle innovation. You don't want people to wait years before a simple program or feature is implemented. And that's the genius. If you look at this Unlocking the Kernel documentary, it was released in Chicago. It's about the history of eBPF. And it's about this group of people, kind of misfits, right? So they wanted to go fast and innovate. And it was just not possible. So they started to implement these small changes within the kernel so to enable these arbitrary commands, the arbitrary programs to be executed. And that was, that unlocked an entire industry, an entire suite of tools and programs to be created. And even today we don't even know where we're going, right? There's so much on the at stake, right? So we can do security, profiling, monitoring, troubleshooting, all through eBPF hooks.
So you can write code and execute it on the kernel directly, yes. But it's isolated.
It's isolated. It's what the JavaScript is for HTML. This is also a very common analogy. JavaScript for HTML, eBPF is for the kernel. So it runs in a VM.
That's slow. Because JavaScript is slow.
No, okay. It's C. So it's not even C.
Speak a pot about Java somehow.
I don't know about it, but it's pseudo C. It's not exactly pure C because it needs to be Of course, you have a subset of the commands because you cannot run any code you want. You cannot run Doom on any eBPF. Maybe somebody did, I don't know. But for example, one of the limitations is that your loop, they cannot be unconstrained. So for example, you cannot just run something forever within an eBPF program. You have to know in advance how many loops, how many iterations you're gonna do. So it's not exactly, it's not exactly C or the commons. So it takes some effort, but the power of running these small programs within the kernel, it's amazing because you are really close to the metal, right? So they are efficient, they consume little memory, they can exchange data with user space through BPF maps. So it unlocked our industry really. So companies like Isovalant, but also Solo.io and others, and there are more on the market that they are working. Falco, for example, is a security tool based on eBPF, and so many more. And so all this innovation is done it was sparkled by this little group of misfits. There was a 2014, 2015, these people at PlumGrid. I don't know if you remember the OpenStack days where we were talking about SDN, software-defined networking. That's where it comes from, right? So from that effort to virtualize, to make everything in software. No more cables to patch, no more top-of-rack switches, but everything done in software.
Yeah.
And that's where it comes from. So.
Okay. But as every new technology, it sounds like the sky is the limit, but there is a limit. There are restrictions, still restrictions.
Yes, of course. So you cannot do everything in the kernel, right? So maybe you should not do that because it's again, it's a sacred space. You don't want to do too much. So, for example, and that's a debate. Of course, you ask different people, you get different opinions. But for example, layer 7 processing of packets.
Yeah.
So the higher level, the one where you inspect a HTTP request and you want to make a decision based on the verb or the response or the headers. Those are probably not too easy to implement in pure eBPF because you have a limitation. And so there's still a market and opportunity to use layer 7 proxies like Envoy, right? So it's not always, of course, like everybody has his own opinions, and there are important people with important opinions, of course, and but definitely there's a space to implement different things in eBPF. So not everything should be done only because we can. We should not do it, but we are seeing already, and last year was a big year for eBPF and for Cilium, which is the container networking interface, the CNI based on eBPF, which is the de facto default CNI now. I mean, not to take anything away from.
Not yet, but I'm hoping.
Now it's becoming like big cloud providers, Azure, EKS, GCP, they all offer their managed service using Cilium. Yeah. So it is kind of like it's the go-to CNI, right? So if I think of a CNI, everybody now think of Cilium.
Yeah.
Rightfully so, because it's performant, it's easy to understand, it works very well. It gives you this Cilium network policies, which are superset of the basic network policies. You can do very interesting stuff, and there's a lot of development going there.
Yeah, the observability is also. But you can see, and with Hubble, you can see really how your network, how your network policies are breaking.
Yeah,
that's nothing standard in Kubernetes. You can't do that.
No, it's a limitation. I mean, it was never meant to be like that, but because of eBPF, you can hook into this low-level kernel events and then visualize the internals of your Linux kernels, which is like it's a no-brainer. It costs nothing because just you already have a kernel, so it's producing these events and signals. You just need to collect them and put them in place like Prometheus, and that's the role of tools.
If you look at the public cloud, so you take a service, you get like a web service,
an
app service, that's not suitable for eBPF, right? Because you cannot then the Microsoft or public cloud provider, maybe more in general, not specific that service, but how can you spin up a service? They don't want you to talk to the kernel of that managed service.
No, it's
You know where I'm going?
But Microsoft may implement it internally, like Facebook created this protocol Catran, which is the eBPF-based load balancer. So every Facebook request when you scroll your Facebook page, it actually goes through an eBPF-based load balancer. So it's about an implementation detail, how they implement it, but because of the cost and the efficiency, and big cloud providers, they work on these low margin things. So they're very low margin. So if they can squeeze every % of performance out of what they already have, for them translate into pretty big money profit, right? So that's why we need to be more efficient. We need to use better what we have. Not only, of course, because we look at the wallet, but also because we are, and I'm part of the environmental sustainability group within the CNCF. So every euro you save, it may also translate into maybe a ton of CO2 you don't need to emit. That will be more and more important as the year progresses, right? So as we are getting towards the goals of the COP28 and so on.
Yeah.
How can I use eBPF for hacking?
For hacking?
Yeah. Is that a viable option, or is that just?
Have you ever used TCP dump?
Yeah.
That's eBPF. So I already use it. It's so ingrained in the tooling we use, we don't even think about it, but actually we are using it. TCP dump was one of the first to implement this introspection, completely transparent, because you're just looking at what's going on without intercepting, without disturbing.
If I write some eBPF code to hack my kernel
that's the role of the verifier, that your programs don't go outside the boundaries, right? So that's where the guardians of the kernel kick in, right? So where
you can see the image rising up.
The movie. So but somebody smart could technically make something malicious based on eBPF. I have no idea. I hope we are not giving ideas to anybody, but
no, of course. But it's something you have to think about to mitigate it in your future. Because if you don't think about hacking or viruses,
to run eBPF program, you need super user privileges, right? So it's not something you can just do as a user. To do that Cisco to load a program in the kernel, you need to have super user privileges. So. And you can think of, if you are compromised and somebody becomes root on your node, it's game over anyway. So it's not like...
But they could implement some eBPF, something to send all traffic to somewhere else, and then do it silently, and then infect something else. And because we had leaky vessels, of course, in Kubernetes some time ago. Still,
it's a supply chain problem. As with software, is always a supply chain, right? So if you get to the point where you can inject malicious code early in the process, right, in the CI stage, then it's game over. But these are most of this stuff is open source, so it's very well scrutinized. And we are not talking of the SolarWinds, where they have like a very black box process where you don't know what's going on. You have open source here, so we're talking most of the tools are open source. So is one thing that makes open source more secure, is because there's so many eyes on it that it becomes very difficult to inject code, eBPF bytecode, into the software we run to exploit something like that. So
but it's always a challenge with new technologies and IT.
But if there is no new technology, there's no progress.
Exactly.
And what are we doing here?
And during the solving of this problem, there will become new technologies.
Yeah. We will be doing COBOL and Pascal.
Oh, that's good. I know Pascal.
Yes.
back to eBPF. You said Cilium is the for Kubernetes is the default CNI now. Is there more software in Kubernetes that connects to eBPF instead of only Cilium?
Yeah, one of my go-to, so something that I always install because it makes me feel safer is Falco. So because I want to know what's going on. I want to be alerted if somebody's even trying to do something malicious. Not only after the fact, but even the simple fact of trying to access the host network or the host file system should trigger an alert, should be an alarm in my clusters, right? So Falco is very popular. It's part of CNCF now. It's graduated actually yesterday or the day before.
Is it production ready now?
It's graduated, so yeah, it is production ready. Yeah, the graduation in CNCF means yes, you made it. Okay. You have a healthy community. Yeah,
because it was not yet production ready, and
for me, everybody has different opinions. For me, it's production ready. That's I totally production ready, and it's like a visibility. So I know what's going on. If I don't have Falco, how do I know there is somebody trying to do something fishy with their pods? Exec into the pod, running processes that are not part of the pod. It's a great tool to have, and something that I don't even think about. I put it in my GitOps repository, and it gets installed on every cluster I have. So that's it.
Oh, what more software do you run instantly?
Yeah? I think everybody. I think we debated this on Twitter or LinkedIn. So everybody is like like a car. No, you have your accessories, right? You cannot live without. I cannot live without heated seats.
Yeah,
I love them, right? So definitely is Falco, Istio. Of course, because I'm
wonder how that came to be.
Yeah, Cilium CNI, Serve Manager, external DNS, that's for sure.
External DNS?
Yes, because I have all my domains. I have so many domains. Sometimes I wake up and I need to register this domain. I don't know if you have the same thing, but I have
maybe it's
too many.
Yeah,
too many. And so external DNS can talk to Azure. All my domains are in Azure DNS. So external DNS, wherever I am, wherever the cluster is, even EKS, even Amazon or Google Cloud, will manipulate the Azure DNS entries, so I don't deal with IP addresses anymore. I have my cluster come up, gets an IP address from the provider, and that IP address is now an entry in Azure DNS.
Oh, that's
so
cool.
I get everything through DNS. I mean, it's a thing of mine. I don't want to type IP address. I have this, and also Cert Manager will ask for let's encrypt certificates automatically. So it's all automated. It's all what I do is I feel that these are the classes I can start to work with.
Okay.
Everything else, and it's all in. I used to do Flux. I should go back to Flux, but now of course I'm an Argo guy, Argo person. So everything is in Argo. There's the repository, and I just install what is there. So we should do it. I should do a demo next time.
Yeah, go ahead.
Go ahead. Yeah. No.
Yeah, I was thinking. I always was comparing eBPF to another technology, but I forgot the name. Yeah, I always had in VMware. You got on the network on the
NSX.
Probably. Yeah. You
NSX. Yeah.
You excluded the hypervisor, so the network traffic can directly talk to the hardware.
Yeah. But that's and actually it's funny because that also came from the acquisition of Ensira. I remember I was around when the OpenStack thing was. So PlumGrid, Ensira, those were the SDN players, right? So then VMware acquired Ensira, and that became NSX.
NSX.
Great tool to do software-defined networking, and I don't know it very well, but it's at the same. It comes from the same pain of having network-defined in software.
Yeah, somewhere in my mind it made the link with that kind of technology.
Yeah, that's definitely right.
Okay. Phew. Thanks.
Now, of course, they diverged.
Yeah, of course,
became a commercial software, and one became part of the kernel, open source. So that's, I think, it's also quite interesting to see the difference. Like, you get acquired by a big company, then you use a commercial software. It's a different path, right? So
Yes.
If I want to start writing eBPF codes,
good luck.
what do you have to learn, and how much work is that? And
Actually, it's less drama than so it's C, of course. Like so,
Yeah, of course. You need
but
C.
C is not too difficult to understand. I mean, maybe writing yourself. Also, today you can ask Copilot or
So not
ChatGPT.
C++ or C sharp,
C-
just
Just C, yeah. So
old version.
good old version.
there are.
I was
there
thinking you wrote assembly or something, you know.
No, there are libraries that let you write programs in Go and Rust.
Sure.
But I don't think there's any. Yeah, that's it. Go, Rust, C++, no JavaScript, transpiler.
Yes.
But,
Yes.
but you have to understand very well how these probes work, right? So what kind of signal you get, how do you want to transfer the data between the two sides of the world, right? So you have to understand BPF maps, how you want to, move stuff around, and it's not trivial, but and I don't know if you want to do that because there's geniuses that work for us, people from the community of Cilium, community of eBPF. They are so smart and they can make this. So I'm a happy user of eBPF. I can contribute, of course, with talks and popularizing and trying to make this technology more understandable. But writing my
Well, this is a good start.
it's a great start. I think
Yeah.
it's
So what are your next plans with
eBPF. I think it's
eBPF,
gonna be more. 2024 is gonna be more and more of this advancement of technology. It's a very interesting time because, of course, Isovalant was acquired by Cisco, so we're all waiting to see how the community is going. Whereas they produce, of course,
acquired by Cisco.
Isovalant was acquired by Cisco. Isovalant doesn't own Cilium, of course.
Yeah, of
It's actually the IP, the logos are trademark from the CNCF because being CNCF involves being nobody owns it.
Yeah.
Just the foundation owns the project. But of course, most developers of Cilium, many developers do work for Isovalant, which is now part of Cisco. Cisco probably was very wise to buy Isovalant because they got all the best, the top contributors in one go. But we know, and we have no reason not to believe the words of the Cilium community that says this is an open source project, nothing's gonna change. Even better with a big corporate sponsor, there will be even more contributions and development in Cilium. So it's actually I believe it's gonna be a big year. Yeah.
Cool. Oh, I'm out of questions.
You're out of question. That does not happen a lot.
Okay. That's totally much. But,
I think it's really inspiring how we can use eBPF to get more information about networking and also just more information from the kernel. So
profiling is a big thing, for example. So to understand where is the hotspot, right? So where is your code spending most of the time? So really gives you this X-ray vision on. I'm running code, but are you sure it's actually running like it should? Is stopping somewhere, waiting for, and these you get all these signals you get from the kernel. Plus it's super fast. I mean, we're talking about nanoseconds to process a package, which is
insane.
It's insane. So it's,
could you do like an APM kind of thing?
Yeah. Falco is kind of APM. Like you get this. It's open source, so you have to put it together yourself. Of course, it's like a Lego, right? So it's do it yourself.
Yeah.
They give you the
Do you know what
instructions.
APM is?
Access.
What is APM?
Protection management. Oh, what? Did I correctly?
APM, it's application performance
Monitoring.
Yes.
Okay, right.
The
So it's end-to-end monitoring. So you're gonna see what the user is doing on the server side.
Sure. Okay.
there are already I don't remember. Ground Cover is working on it. There's a Parka, very interesting projects, and all of a sudden it's like gabber music, which is really appropriate.
Recording live podcasting, you know?
Yeah.
But anyway.
That's, my wife loves this music.
Yeah, well, I signed me up, but
I don't know.
just wait.
Funny thing, I used to work for AD&T and Q-Dance, so I was going to a lot of this art style music.
Cool. Well, not to take much longer of your time, because you have a boat to get to.
Yeah, so they're not living without me, right? So
No. So, where can people find you if they haven't found you already?
we're doing more meetups, of course. We're organizing, in the Netherlands, there's a lot of attention to environmental sustainability in cloud native. So we are gearing up for Environmental Sustainability Week in October.
Yeah.
We did it last year with, that week, all was like I don't remember the number, but we made dozens of meetups all across the world doing that week a meetup dedicated to environmental sustainability.
Nice.
So we want to double down. We want to really.
When is that?
We haven't decided. Probably the last week of October. We're gonna announce it, of course. We're gonna do like a bigger meetup because this is so important. I mean, I have kids.
Yeah.
We need to leave a better planet than we found, right? So we need to think of, are we doing the right thing? Are we saving money and saving careful when we run our workloads? So this is an important time. This is one of the big trends in cloud native. There's a technical advisory group, which I'm proud part of, and there was a keynote at Chicago, and there's going to be more keynotes with this topic in Paris. And so expect a lot of talks about it. And the big players are paying attention. Intel, ARM, they're all really interested in getting more carbon aware, right? So
Thank you very much, Alessandro. See you
so
next
much.
time.
Anytime.
Thank you very much.